All right, guys. Perform a string search using bin text. Let's see what we got. Software programs include some strings that are commands to perform specific functions such as printing output. Strings communicate information from a program to its users. Various strings that could represent malicious intent of a program, such as reading the internal memory or cookie data, are embedded in the compiled binary code. Searching through strings can provide information about the basic functionality of any program during malware analysis. Search for malicious strings that could determine harmful actions that a program can perform. For instance, if the program accesses a URL, it will have that URL string stored in it. You should be attentive while looking for strings and search for embedded and encrypted strings for a complete analysis of the suspect file. Bin text is a text extractor that can extract text from any file, and it includes the ability to find plain ASCII text, Unicode text, and resource strings, providing useful information for each item. Here, we will use the bin text tool to extract embedded strings from executable files on the Windows machine. Oh, hello. Right, there we go. Okay, so on the Windows 10 machine, we've navigated to malware threats. We're doing malware analysis tools up top here. Tools for prepared. Oh my gosh, let's get back up here. Wait, am I going down the wrong file path? Hang on. Static malware analysis tools. Let's see what we got. Bintext, bintext.exe. All right, Bintext main menu window appears. Click Browse to provide a file to scan. So we're going to look for a malicious file in here. I wonder if they have the old files I was using. Okay, well, they want me to look under here. So CE tools. And I'm going to use a different virus. Let's go to viruses, face. I guess the executables are down at the bottom. No. Where are you? Oh, there it is. Wait, no. Did I lose it? There we go. All right, face.exe, open. So the bin text extracts provided malicious files, critical information as shown in the screenshot. Cannot be run in DOS mode. This type of string is designated by a colored letter to the left of the list. So ANSI strings are marked with green A. Unicode strings have a red U. And resource strings have a blue R. I didn't see any blue R's. I saw red U. Yeah, I don't see any R's in this one. Okay. No resource strings. File position is the hex position at which the text is located in the file. Where is that sucker? So much information in this freaking. Ooh. Okay. Huh. I don't think that hello went through. Hello, world. Let's do that again. There we go. Mem position is if the file is a Win32 PE file, such as Windows 95 EXEs and DLLs, then this is the hex address at which the text is referred to in the memory at runtime as determined by its section table. ID is decimal string resource ID or 0. Let's see if I can find any of these suckers. Okay. All right, so we pretty much looked at that virus. Attackers often use packing and obfuscation. You know, this is a question I've had is how do you say that word? So let me see if I can do this real quick. Whoa, why is my caps lock on? Obfuscation. It means camouflage, from what I understand. Obscure, unclear, or unintelligible. Obfuscation.
Obfuscation.
Oh, obfuscation. Oh, I was pronouncing that incorrectly. Well, I learned a new English word today. Let's see. Attackers often use packing and obfuscation or a packet to compress, encrypt, or modify a malware executable file to avoid detection. Obfuscation also hides the execution of the programs. When the user executes a pack program, it also runs a small wrapper program to decompress the pack file, then runs the unpack file. It complicates the task of reverse engineers to determine the actual program logic and other metadata via static analysis. The best approach is to try and identify if the file includes packed elements and locate the tool or method used to pack it. PEID is a free tool that provides details about Windows executable files. It can identify signatures associated with over 600 different packers and compilers. This tool also displays the type of packer used in packing a program. Here we'll use the PEID tool to detect common packers, cryptors, and compilers for PE executable files. So let's go back here, Where are we? No, malware analysis tools, static malware analysis tools, packaging and obfuscation, PEID, PEID.exe. Okay. So I'm guessing this is the browse button. All right, what do they want me to load? They want me to load the virus face.exe. Okay, where's that sucker? Oh, wow. I didn't realize there were that many. All right, so face.exe. As soon as you click open, multiscan. Yeah, so warning, hey, this is a virus. Let's see. You can also use other packaging obfuscation tools such as MacroPack, UPX, or ASPack to identify packing obfuscation methods. So, task 4, find the portable executable information of a malware executable file using PE Explorer. Portable executable format is the executable file format used on Windows OS ES that stores the information a Windows system requires to manage executable code. The PE stores metadata about the program, which helps in finding additional details of the file. For instance, the Windows binary is in PE format that consists of information such as time of creation and modification, import and export functions, compilation time, DLLs, and linked files, as well as strings, menus, and symbols. PE Explorers lets you open, view, and edit a variety of different 32-bit Windows executable files, so called PE files, ranging from common files such as exe, DLL, and ActiveX controls, to less familiar types such as SCR, screensaver, CPL, control panel applet, sys, MS styles, BPL, DPL, and more. Here we're going to use the PE Explorer tool. All right. Let's go. PE extraction tools, PE Explorer, PE setup. Let's see what we got going on here. Okay. There we go. I was like, that did not pop up. All right, so click open file from menu to start exploring. Open file. All right, so we're going to do the face.exe. Man, I just straight up smell like gasoline right now. Holy cow. I got a lot of gas in my hands. So high, yeah, from gasoline, it is me. I don't know why, but I really love the smell of gasoline too. It smells good. Okay, where am I at? Virus live. You want me to do the face.exe again? Just continue. Okay. So the headers info provides you with the ability to view and save a text report on the file headers for information, modify the entry point value, update the values of the checksum header, set flag bits in the file header characteristic files. Click the data directories section icon. It's header info, data directories. All right, ability to view and edit. The virtual address and size of chosen directory describing provisions of parts of code. Trailing array of data directories cover pointers to the data in the sections. Okay, click section headers. There's section headers. Icon from the menu bar. This will provide you with the section headers information, allowing you to view all sections and information about their location and size. Double click on any section to view the raw content. You have entered the matrix. Okay, who took the red pill? Holy crap, dude. All right, so we're closing all open windows. You can also use other PE extraction tools such as Portable Executable Scanner, Resource Hacker, or PE Viewer. Find portable executable information of a malware executable file. All right, cool. Task 5, identify file dependencies using Dependency Walker. Any software program depends on the various inbuilt libraries of an OS. Helps in performing specified actions in a system. Programs need to work with internal system files. To function correctly, programs store their import and export functions in a kernel 32.dll file. File dependencies contain information about the internal system files that the program needs to function properly. This includes process of registration and location on the machine. Find libraries and file dependencies as they contain information about the runtime requirements of an application, then check to find and analyze these files. To provide information about the malware in the file, file dependencies include linked libraries, functions, and function calls. Check the dynamically linked list in the malware executable file. Finding out all library functions may allow guessing about what the malware program can do. You should know the various DLLs used to load and run a program. So these are standard DLLs. Kernel 32.dll, core functionalities such as access and manipulation of memory, files, and hardware. AdVaP 32.dll provides access to advanced core Windows components such as Service Manager and Registry. User 32.dll user interface components such as buttons, scroll bars, and components for controlling and responding to user actions. GDI 32.dll functions for displaying and manipulating graphics. NTDLL.dll interface to the Windows kernel. WSOC 32.dll and WS2_32.dll networking DLLs that help to connect to a network or perform network-related tasks. Winanet.dll supports higher-level networking functions. The Dependency Walker tool lists all dependent modules of an executable file and builds hierarchical tree diagrams. It also records all functions that each module exports and calls. Further, it detects many common application problems such as missing and invalid modules, import and export mismatches, circular dependency errors, mismatched machine modules, and module initialization failures. Here, we will use the Dependency Walker tool to identify the file's dependency of an executable file. All right, so file dependency checking, Dependency Walker, depends.exe. All right, so navigate to File. I could have just hit open right there, but okay. Open window appears, navigate. Sure. I think it's under this PC. Yep. All right. Oh, there it is. Snoopy. Shrink the .dll nodes. Oh, wow. Yeah, I've never used any of those, so I don't know much about them, but this is pretty wild. For malware disassembly using IDA and OllyDbg, static analysis also includes the dismantling of a given executable into binary format to study its functionalities and features. This process helps identify the language used for programming the malware. Look for APIs that reveal its function and retrieve other information based on the reconstructed assembly code. You can inspect the program logic and recognize its threat potential. The process uses debugging tools such as IDA Pro and OllyDbg. IDA is a disassembler. IDA explores binary programs for which the source code might not be available to create maps of their execution. The primary purpose of a disassembler is to display the instructions actually executed by the processor in a symbolic representation called assembly language. However, in real life, things are not always simple. Hostile code usually does not cooperate with analysts. Virus, worms, and Trojans are often armored and obfuscated as such. More powerful tools are required. Debugger and IDA complements the static analysis capabilities of the disassembler by allowing an analyst to single step through the code being investigated. The debugger often bypasses the obfuscation. It helps obtain data from the more powerful static disassembler will be able to process in depth. OllyDbg is a debugger that emphasizes binary code analysis. Oh, yeah. Finally got it pop. Which is useful when source code is unavailable. It traces registers, recognizes procedures, API calls, switches, tables, constants, and strings, and locates routines from object files and libraries. There is a new debugging option, set permanent breakpoint on system calls. When active, it requests OllyDbg to set breakpoints on kernel 32, unhandled exception filter, and all those other ones. All right, so now let's go to seeing tools. Malware threats, malware analysis tools, static malware analysis tools, disassembling and debugging tools, IDA free 70. All right. Hit yes. IDA. All right. We're gonna say sure. Next. Next. All right. New. All right. Select file. Down here. Module 07. Viruses. It always eludes me. Face.exe. Go. Click open. Just click OK. Okay. Right, minimize. And we're going to copy this file, copy. In the C drive, program files. There's all right. This file there. Continue. All right, so it's there. My view graphs. And I get the view graphs flowchart. Okay, close the graph. View graphs. Function calls. What the frick? Oh my gosh. How do I zoom in on this sucker? I can't even read that. Oh my gosh. Control plus. Okay. Oh, hey. Good day to you as well, Oliage. Sorry, I'm getting so into this file. You know, just so amazing. Oh man, I get so distracted sometimes trying to find these things. Let's see. All right, I'm in static malware analysis tools. Let me just put in a good day to you as well, my good sir. If I can type, here we go. I sometimes think of Gentleman Cho'Gath. Pip pip cheerio. I always love playing League of Legends as Gentleman Cho'Gath. That was like the must. Okay, let's see what I got over here. Static threats or malware analysis tools. Oh my gosh, why am I having such a... My sexdysia is messing up today. Dyslexia. Less dysic. I don't know what else to call it. Man. All right, so we're going into the OllyDbg, seeing how it reads files and stuff. All right. What do you want me to write? This executable. Okay. You do not have administrative rights on this computer. As a result, some debugging features may fail. Okay. Yeah, I've got all the sub windows that they're talking about. So we're going to check a file. And we're going to just open... Which file do they want me? They want me to do the... Yeah, teeny. Okay, that's good. So we're going to open that file. Unable to locate file. Really? It won't do it for me. That is odd. All right, let me see if I can... go back. CE tools, module 7. Let's go here. Let's go to the viruses. There should be a teeny.exe. Okay, let's open that one. There we go. I think there's 2 teeny.exes. It's great. All right. So we got our outputs. Main thread module. So choose view in the menu bar and then choose log. View, log. There's tons of DLLs here. Kernel 32, WS2_32, NT DLL.dll. So a window named log data appears, displaying the log details as shown. Log data also displays a program entry point in its call to known functions. Close the log data window. After completing the analysis, choose view and choose executable modules. Dang, man. This thing has so many DLLs. A window named executable module appears, displaying all executable modules. Double-click any module to view the complete information. Ooh. Holy crap, dude. Let's see. In this exercise, we're choosing that. This will redirect you to the CPU main thread window. Choose view and memory. Okay. A window named memory and map. Memory map. Oh, so that's all the memory map, man. The whole thing. It's crazy. It's so much information. Choose view in the menu bar, then choose threads. Okay, window named threads appears in OllyDbg, displaying all threads as shown in the screenshot. This way you can scan files and analyze the output using OllyDbg. Yeah, I've never used any of those, so I don't know. But yeah, this is crazy amount of information. Like, all right, that's good. Next. So, perform dynamic malware analysis. Dynamic malware analysis, also known as behavioral analysis, involves executing malware code to learn how it interacts with the host system and it impacts after infecting the system. Dynamic analysis involves execution of malware to examine its conduct and operations and identify technical signatures that confirm the malicious intent. It reveals information such as domain names, file path locations, created registry keys, IP addresses, additional files, installation files in DLL, and linked files located on the system or network. This type of analysis requires a safe environment, such as machines and sandboxes, to deter the spreading of malware. That's weird that they say machines. I agree with the sandboxes. Maybe if they meant virtual machines, but you don't want to like try it on your own system to see what happens. Try it on a crappy computer. I guess that's what they mean. I don't know. Environment design should include tools that can capture every movement of the malware in detail and give feedback. Typically, systems act as a base for conducting such experiments. An ethical hacker and pen tester must perform dynamic malware analysis to find out about the applications and processes running on a computer and remove unwanted or malicious programs that can breach privacy or affect the system's health. So this is what we're going to do in the labs. Cool. Overview of dynamic malware analysis. I feel like the other overview was the overview, but let's beat a dead horse. Sure. We want to make sure that we don't propagate this to our actual network. It's just like another paragraph of saying, hey, don't do this. It's bad. So, all right. Let me see if I can do this. Dude, I can't believe I've been doing this. Why did nobody tell me this? I wasn't sharing my screen. I am so sorry. Oh, hide this. I always forget that on Restream. Anyways. So you guys didn't see any of the stuff I was doing, which is fantastic. Ugh. Goober. Sorry, guys. I'm goobing. I'm goobing today. Just being a goofy goober. All right. System baselining refers to the process of capturing a system's state, taking snapshot of the system at the time the malware analysis begins. This can be used to compare system states after executing malware file, which will help understand the changes that the malware has made across the system. Let's see, open ports, network activity, and other items. So host integrity monitoring is the process of studying the changes that have taken place across a system or a machine after a series of actions or incidents. It involves using the same tools to take a snapshot of the system before and after the incident actions and analyzing the changes to evaluate the malware's impact on the system and its properties. So host integrity monitoring includes port monitoring, process monitoring, registry monitoring, Windows service monitoring, startup program monitoring, event logs monitoring, and analysis, installation monitoring, device driver monitoring, network traffic monitoring and analysis, DNS monitoring and resolution, API calls monitoring. All right. So I actually have to go to class and learn some things. I apologize about not sharing my screen. You guys didn't see pretty much anything about IDA and all the debugging software, OllyDBG. I do need to go to class, though. So thank you so much for your time. Sorry about the technical difficulties. I always forget that silly little thing. So we'll save this for another day. All right. See you guys.